This is 10.3, Solving Radical Equations. A radical equation is an equation that contains a radical expression with a variable in the radicand. So that means a variable is inside the square root symbol. To solve a radical expression, we're going to use properties of equality to isolate the radical, then square each side to eliminate that radical, and solve for the variable. So it's doing the same thing that we've been doing the entire time, is solving for whatever variable we have. It's just when we get to the radical, we need to square each side because that squaring and square root are inverse functions. They cancel each other out. So to get rid of the square root symbol, you square it. And what you do to one side, you have to do to the other. That's what the properties of equality say. So we are going to solve 2 square root x plus 6 equals 10. I'm working to get x by itself, so subtract 6 on each side. And then I have 2 square root x equals 4. Divide each side by 2. And then I get square root of x equals 2. To get rid of the square root, you square it. And what you do to one side, you have to do to the other. So you get x equals 4. And I could plug that back in to my equation. 2 times square root of 4 plus 6. Square root of 4 is 2. 2 times 2 is 4. 4 plus 6 is 10. So that works out. I'm going to solve x plus 4, the square root of x plus 4 plus 7 equals 11. So this plus 7 is not under the radical, so I'm going to subtract 7 on each side. Then I have square root of x plus 4 equals 4, so square each side to get rid of that radical. X plus 4 is 16, subtract 4 on each side, and x is 12. Here I have 15 equals 6 plus the square root of 3w minus 9. Subtract 6 on each side to get the radical by itself. Then once the radical is by itself, you square each side and then get your variable by itself, and we get w is 30. Here I have 2 radicals are already equal to each other. So the radicals are by themselves on each side. So I'm going to square each side to start. Then I get 3x plus 1 equals 4x minus 7. Put all variables on the same side. And then put all constants on the other side. And I get x equals 8. For the cube root of y minus 4, I'm going to still get this radical expression by itself. So I'm going to add 4 to each side. Then I have cube root of y equals 5. And the index and the power need to match. So cube root, I'm going to cube each side. When we don't have any number in this index, it's an invisible 2. So this is the cube root and the cube cancel each other out to leave just y. And 5 to the third power is 125. Here I have cube root of 3c plus 7 equals 10. And the square root, the radical expression, is already by itself, so I need to cube each side. Then I have 3c plus 7 equals 1,000. Solve to get my variable by itself, and c is 331. Here I have 3m plus 10 equals 1. So to get my radical expression by itself, subtract 10 on each side. Then I square it, because the index here is a 2, so square it and they cancel. To get 3m is 81, divide each side by 3, and m is 27. So if I take m is 27 and plug it back in, I get 3 times m, so 3 times 27 is 81. Square root of 81 is 9. 9 plus 10 is 19. That's not 1. So since this is not true, we call this an extraneous solution. So it's important to plug your answers back in to make sure they work. I have a good clue here that I have a square root equals a negative number. A square root cannot equal a negative number, so this is a clue that something could be weird in my answers.